Already we have discussed about decision tree induction algorithm in classification, right? And there we have seen, based on different attribute selection measures, information gain, Gini ratio, right, Gini index, we have selected the root node or the best node to start the decision tree. Means we have analyzed all the nodes, sorry, all the attributes, and from the calculations of information gain or the Gini index, we have find the best attribute to start with the root node, and in same way we have find the middle nodes also. So, and this way we have designed the decision tree, right? I will give this one to you also, because some students have not designed the decision tree correctly. So I will give this handout so that you can draw the decision tree correctly, right? So today we will discuss about the next classification method. This is the Bayes classification method, right? There are some disadvantage of uh, decision tree algorithm, right? So what are the disadvantages? A small change in the data, means what the data set you have, if you change, that can cause a large change in the structure of the decision tree, right? Means if you change small, then it can cause a large change in the structure of the decision tree, and it is causing the instability, fine. And obviously sometime calculation can go far more complex compared to other algorithms, right? This is another disadvantage. Next, it involves higher time to train the model, right? And obviously it is relatively expensive as complexity and time taking is more. And there is another disadvantage, that it is this algorithm is inadequate, right? Not sufficient to apply the regression and predicting the continuous values, right? So these are the disadvantage of the decision tree algorithm, right? So there is another classification. This is the Bayesian classification. This is not the counterpart, means, of the decision tree, but this is another type of classification algorithm, right? Which is proposed by the Thomas Bayes, right? And sorry. So today we will discuss about this classification. So what are the Bayesian classifier? Right. So it is the statistical classifier. Right. This the here this classifier is the statistical classifier, which predict the class membership probabilities. Right. Suppose that the probability that a given tuple belong to a particular class or not. Fine. This classification is based on the Bayes theorem, right? And this classifier is working well if you compare with the decision tree algorithm, right? It is working more efficiently than the decision tree algorithm when you apply the classifier for a large database, right? So I'm correct directly coming to the Bayes theorem now, right? So what is the Bayes theorem? Just listen very carefully. Let X be a data tuple, right? And in this Bayesian theorem, in this Bayesian theorem, this X is considered the evidence, right? And it is described by measurements made on a set of n attributes. Fine. So there are n attributes are there, and this is the data tuples. It's a data sample, you can say, or here it is known as the evidence. Right? It's very simple. Now let H be some hypothesis such that the data tuple X belongs to a specified class C. Right? Suppose if you remember that Bayes customer, so the two classes were there, right? So Bayes computer yes and Bayes computer no. So suppose H be the hypothesis, or H belong that some tuples are there which belongs to that Bayes customer yes, like that. Fine. I'm coming to the example, then it will be easy. For classification problem, next we need to determine this P Hx, right? Means the probability that the hypothesis H holds given the evidence data tuple X, right? Means P H of X means it is the probability that the hypothesis H holds or satisfied given on the X data tuple. Fine. So this is the first one that you need to remember. You need to find that probability, or you can say that we are looking for the probability the that the tuple X belongs to class C, right? Means we are looking for the probability that tuple X belongs to class C, given that we know the attribute descriptions of X. Means we know about the X, right? That tuples. So by knowing this X tuples, we are looking for the probability of tuple X which belongs to that class C. So this is PHX, right? Next one is what? So this PHX is the known as the posterior probability, right? So this PHX is known as the posterior probability, or you can say, or in some you will see there is a posteriori probability, right? So this PHX is the posterior probability of H conditioned on X. PHX is the posterior probability of H conditioned on X, right? So suppose in our data set, if you remember that data set, so there are age was there, income was there, right? If you remember this data set, if you remember this data set, right? So suppose the data tuples are described by the attribute age and income, right? Okay, so and X is a middle-aged customer with an income of suppose medium, right? Suppose the income of suppose 40,000 per month. So this H is the hypothesis that our customer will buy a computer, right? So suppose H is the hypothesis that our customer will buy a computer. Fine. So suppose X contains two attributes, is age and income, and we have considered that age is medium and income is 40,000 per month, and the hypothesis is that our customer will buy the computer, right? Then what will be the posterior probability? Means what will be the HX? That it is reflecting the probability that the customer X will buy a computer, given that we know the customer age and income. Is it clear? PHX reflects the probability that the customer X will buy the computer, given that we know the customer age and income. Clear? Fine. So next I'm coming to PH. It is the prior probability. It is known as the prior probability or the initial probability. So what is it? So same example I'm giving, that the probability that any given customer will buy a computer regardless of age and income or any other information, right? So it is the prior probability, means This is the probability that any customer will buy the computer regardless of age, income, the credit rating, right? So you can say the posterior probability PHX is based on more information than the prior probability, right, which is independent of X, right? So this one is what? Independent of X. Next is the PX. It is the prior probability of X. It is what? This is the prior probability of X. So it is, you can say that it is the probability that a person from our set of customer is medium age and earn 40,000 per month, right? It is the probability that a person from our data set of customers whose age is medium and earns 40,000 per month, like that. Okay. Similarly, this PXH means the probability of X conditioned on H, just opposite of this one, probability of X conditioned on H. So it is the probability, suppose that a customer X is middle age and earns 40,000 per month, given that we know the customer will buy a computer, right? Means, just what is the PHX? That the customer, what is that PHX? That the customer will buy the computer given that we know the customer age and income. This is the P age conditioned on X. And what is PX conditioned on H? We know the customer, the customer age is middle age and he is earning 40,000. Given that we know the customer will buy the computer, right? So these are the different probabilities we use in our theorem. So this is the Bayes theorem, that P H conditioned on X equals to Px condition on H into Ph divided by Px, right? So it is required the concept of the probability, right? It is requiring the concept of the probability to find to use the uh, Bayes theorem, right? So now we will find how this classifier is working based on this Bayes theorem, how this name Bayesian classification is working based on this Bayes theorem. Fine. So this again we will discuss. So the steps. So let D be a training set of tuples, right, and their associated class levels. So we have a training set already. You know we have that training set, right? So each tuple is represented by n dimensional attribute vectors. This, right? So these are the value of the tuples. And there are n attributes. This is a1, a2, a3 up to dot 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 an. Right. So let D be a trading set of tuples and their associated class labels. Each tuple is represented by an n-dimensional attribute vector, that x, and there are and these tuples are made on n attributes, right? A1, A2, dot dot an. Suppose that there are m classes, right? In our example, we have two classes: by computer yes, by computer no. So there are two classes. So suppose there are m classes, C1, C2 up to Cm. Given a tuple x, the classifier will predict that x belongs to the class having the highest posterior probability conditioned on x. So the classifier will predict that x belongs to the class having the highest posterior probability conditioned on x. Means the naive Bayes classifier predicts that the tuple x belongs to the class Ci if and only if just just a minute. And some points are missing there. So we have the uh, training set of tuples and their associated class levels, and each tuple is represented by n attribute vectors, which is x, made on the tuple from n attributes, and these attributes are a1, a2, such that up to an. Suppose that there are m classes c1, c2, cm, and given a tuple x, the classifier will predict that x belongs to the class having the highest posterior probability condition on x, right? So this is the condition, means the name Bayes classifier predicts that the tuple x belongs to the class Ci if and only if p, probability of Ci conditioned on x, is greater than probability of Cj conditioned on x, where j is from 1 to m and j is not equals to I. So this is the condition to find the or to derive the maximum posterior probability, right? It is maximizing probability of Ci based on or conditioned on x. Okay, so the class Ci, and you can derive this probability of Ci conditioned on x by using the Bayes theorem. Fine. Now since px is constant for all classes, right? Already you have seen that it is constant for all classes. So only this portion need to be maximized, right? And if the class pair probabilities are not known, then it is assumed that all the classes are equally likely, means PC1 equals to PC2 equals to PC3 and dot 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 PCM, like that. So in that case we need to maximize only probability of X conditioned on Ci, means if all the classes are equally likely, means all the probability of all classes are same, then only you need to maximize this one, right? And otherwise you need to maximize as a whole this probability of X conditioned on Ci into probability of Ci, right? And how can you find this PCI? Already you know this is mod of CID divided by mod of D, right? Where CID is the number of training tuples of class Ci and D. Already you have done in decision tree algorithm, right? So now here you need to take the assumption, right? Because now you have to find the this one P of probability of X condition on Ci, because you already know about of this value. So now you have to find the value of this. So how to find this? So here you need to take an assumption. So what is the assumption? This is known as the class condition independence. And what is it? It assumes that the attribute values are conditionally independent of one another, right? The attribute values are conditionally independent of one another given the class level of the tuple. Means there are no dependence relationship among the attributes. This is the class condition independence, means all the attributes are independent of each other when you are taking the class level of that particular tuple. Fine. So since these are independent, so you can say that probability of X conditioned Ci, this is the what? Multiplication of this, right? This is the X1 condition on C1. So here what are the tuples belongs to Ci, this one, what are the tuples belongs to uh, other class, what are the tuples belongs to other class, and dot dot dot. And when you multiply this, then ultimately you will get the probability of that tuple set based on conditioned on Ci, right? So it reduced the computation cost, right? Now there are two conditions can came, right? If AK is categorical, then you can easily find that this one, right? You can easily find the value of this is the number of tuple of the class Ci in D having the value xk for AK, means for individual tuple you will find the in which class it is, and then you can easily find divided by the mod of CID, right? The number of tuples, what you have done in decision tree. But if AK is continuous valued, then we need to calculate in another way. So here you need to assume a Gaussian distribution with a mean mu and standard deviation sigma, and this is the Gaussian distribution, right? What is it? So this is the Gaussian distribution x mu sigma. This is the value, and the probability of x condition of Ci is what? This is g of xk mu Ci sigma Ci, right? So here we have to compute that mu Ci and sigma Ci, obviously. Okay, so now you can understand with an example that the class level attribute be the bicomputer, right? Already in our example, in our data set, what are the class level attribute? This is the bicomputer. So we are considering the associated class level for x is yes. Means we are considering the class level bicomputer equals to yes. And suppose the age is continuous valued, right? So according to data set, suppose according to data set, it is given that the customer who buys a computer are of 35 plus minus 12 year of age. Is it clear? Means suppose the customer, according to the data set, that the customer who are buying the computer, means whose class level by computer is yes, their age is what? According to data set, this is 35 plus minus 10, suppose, right? So this is 35 plus minus 10. So this is the range of the customers who are buying the computer, right? So then what will be the mu? What is the value of the mu? Mu is what? Mu is the mean. So what is the value of mu? This is 35. This is the average age. And what is the standard deviation? What is the sigma? This is 10, right? Because the age range is 35 plus minus 10. So mu is what? This is 35 and sigma is 10. Fine. So now then you can easily find the value of this, right? Is it clear? Means now that suppose x1, this is 35, you know the value of mu and sigma, then you can easily find the Gaussian distribution, and then from there you can easily find the probability of x conditioned on Ci, right? So next one is, so to predict the class level, so you need to compute the value of this, and obviously it will give you the, you need to choose or in the maximum posterior probability, right? Means the predicted class level is the class Ci for which that Px conditions on Ci into PCI is the maximum, right? So this is the steps to of the naive Bayes classifier, right? So various empirical studies of this classifier have been found, and according to theory, the error rate is minimum in compared to the other classification algorithm. But in practice, it is totally depend on the situation, right? It is totally depend on the class condition independence, right? So now I'm going to the example, this example, what we are talking about. So two class levels are there. This is yes and no. Okay, and we have taken that data sample, right? Means we wish to classify X, where age is youth, income is medium, student is yes, and credit rating is fair. So we will classify this tuple. Okay. So we need to maximize that P. We need to maximize this one, right? This one. We need to maximize this one. I need to find the value of this. So first, what we will do, we will find the PCI. This is the prior probability of each class. So according to this, there are 9 yes and 5 no. So this is 9 by 14 and this is 5 by 14. Clear? Fine. So now we will find the probability of X conditioned on CI. Right? There is one mistake is there. This will be the youth. So probability of, so now see, so we have age is youth, income is medium, student is yes, and credit rating is fair. So we have taken this classify. So against each there are two class levels. Against youth yes no, against medium yes no, against student yes yes no, and against fair yes no, like that. Okay, so we will compute this px of ci, conditions on ci. So first age is youth and bias computed is yes. So youth and yes 1 and 2, so two tuples are there, right? And how many classes are there for yes? 9. So this is 2 by 9. Similarly, age is youth, computer is no. 1 2 3 3 3 3 1 2 2 3. This is 3 by total number of no is what? 5. 1 2 3 4 5. So this is 3 by 5. Is clear? Income is medium. So now medium yes. So income is medium yes. 1 1 1 2 3 4. And how many years are there? 9 years. This is 4 by 9. Similarly, medium no, medium and no is 2 by 5. So in the same way, we have find the PXI, all the values. Clear? So ultimately, what will be the value? The multiplication of all this according to the formula, right? So this is P of X conditioned on Ci. For yes, it is this, and for no, it is this. Means we have multiplied all the yes value and I have multiplied all the no value. So this is for yes and this is for no. Then you need to find this value. This is Px conditioned on Ci into PCI. Okay. So it is the value and this is the value. So now, according to this, you need to take the maximum one, right? So which one is giving the maximum? This one. So X belongs to the class yes. Means that this classifier predicts that for this tuple, what you have considered, this one, the customer will buy the computer. Clear? Means the tuple which you have taken for the classification. So according to the Bayes theorem, Bayes classification, it is showing that it will buy the computer. Clear? There is another example of this weather. So that also you can check in the same way, right? So for each you have find all the px condition of ci, and then again it has find that value, right? And then this one is greater than this one, so obviously it is don't play like that. So that you can do as your homework. Fine. Means you will take the classification, you will take the sample like that, and you will find that which class it will belong according to the classification, right? So now, so this is all. So there is one disadvantage, one problem is there. So what if the probability values of are 0, right? Means if there is the occurrence of 0 probability, means there is no any data set, suppose, or there is no any data set for which the um, class level is no, like that, right? So in this case, how you can tackle the problem? So suppose we have since in our example we have by computer yes and by computer no, and there are no any attribute, or there are no training tuple that for which the Bayes computer, I mean the class level Bayes computer no is there, means there is no any training tuple set for which and the training tuple set are and the for which the uh, class level is no, right? Means what, for some value of this, means this is what, this is multiplication of p xk based on ci. So since there is no tuple based on a given condition, right? So obviously what, so it is a multiplication of this, so automatically it will lead to 0, right? Right, means this will return you the 0 probability, but the other probabilities are there. This is one problem. So now to avoid this problem, we can assume that our training data with D is so large that we will add 1 to each count, so that it can avoid the 0 probability, right? And this technique is known as the Laplacian correction, or the Laplace estimator. Means suppose if we have q count to which we will add 1 to each count, and we will divide this by the total number of addition what you have done. Means if you have the q count to which we add 1 in each, so we must remember to add q to the corresponding denominator. So it is better that means if I give an example, suppose there are data set of 100,000 tuples. Suppose that that for the class by computer yes, there are 1,000 tuples and there are 0 tuples with income low. Means total number of tuple is 1,000, where with income low there are 0 tuples. Means income low and by computer yes, so number of tuple is 0. So it is the case of the 0 probability. 990 tuples with income medium and 10 tuples with income high, right? So total 1,000 tuples are there. So according to the Laplace correction, so obviously since the 0 tuples against the income low, so obviously it will lead to the 0 value, right? So this is the 0 probability. Now how to correct by using the Laplacian correction? So we are adding 1 to each case, right? We are adding 1 to each case. Fine. So now probability of income is low. So this is equals to what? How many counts are there? 0. It was before 0. This is 0 plus 1. We are adding 1 by total number of counts. So before it was 1,000. Now how many counts are there? We are adding 1 with low. We are adding 1 with medium. We are adding 1 with high. So total 3 1 has been added, right? So this is 1 by 1,000 plus 3 means 103. 1,003, sorry. So what is the value? This is 0.001. Before it was 0, but now it is not 0. This is 0.001. For this medium, before it was 990. This is 990 plus 1, right? Divided by 1,000 by 3 plus 3. So before the value was what? This is 990 by 1,000. This is 0.99. Before this Laplacian correction, so what is the probability? This is 990 by 1,000, right? So this is 0.99. But now this is 991 by 1,003. Now the value is what? 0.988. So there is a minimal of difference of these two values, right? Similarly, for income high, before it was 10 by 1,000, which is 0.010. Now it is 10 plus 1 by 1,000 plus 3. So it is now 0.011. So by this way, you can avoid the 0 probability. Clear? Using the Laplacian correction. So this is the naive Bayes classifier. So obviously some advantages and disadvantages are there. This model means that the naive Bayes classifier model has a solid mathematical foundation and stable classification efficiency, right? It has the higher speed of for large number of training and queries. It works well for small scale data also. It can handle multi-category tasks and is suitable for incremental training. Means it can train new samples in real time. It is less sensitive to missing data. Means the algorithm is also relatively simple, often used for text classification. It explains the result in a good way. Right. So these are the advantages. What are the disadvantages? The main disadvantage is what is the assumption of sample attribute independence, right? So this is one of the disadvantage. Means if the assumption is not correct, so it will lose the accuracy. It needs need to calculate the pair probability. Means there is an error rate in the classification decision. Right? So all these are the minor disadvantages related to this class condition independence. Otherwise, it is working fine. And to remove this uh, disadvantage, there is another based on this is Bayesian belief network. Is this means it representing all the dependencies among the subsets of attributes. And as you can see that by using this one, this is not actually important for there. So I'm just giving one example. Or so here basically it allows the conditional independencies between different subsets of variables. It provides a graphical model of the relationship of causal relationships on which the learning can be performed. Right. So this is all about the Bayesian classification, Bayesian classifier. Just practice based on the data set. I hope you will understand. Thank you.